we'll continue from the characteristics of DC generator, as we have already seen that various types of DC generator as well as the EMF equation of DC generator. So here as characteristics which will shows us that various starting characteristics as well as internal characteristics where no load as well as load characteristics will we will learn. So in the characteristics, the first one, that is a no load saturation characteristics, which is already known as open circuit characteristics. Okay, so in that characteristics again, the generated EMF which will plotted against the field current. Okay, so that is the graph between EMF generated in armature and the field or excited current at a fixed speed. Okay, so like that way we will see for every single motor the generator we will see one by one. Then in internal characteristics, that characteristics are in between armature current versus armature current versus, you are going to speak or not? It is armature current versus generated EMF. Okay, and third characteristics is external characteristics, that is a load current versus value of terminal voltage. Okay, so we can say an external as well as load characteristics, or we can say voltage regulation curve which is plotted between the terminal voltage and load current when speed is a constant term. Okay, so here we will see for the separately excited DC generator. Again, for the separately excited DC generator, we will see internal as well as external with load characteristics we will see here. So in that separately excited DC generator, that field winding is connected to the separate source. See here you can check where the field winding is connected with extra or separate source of DC power. Okay, and here the one rheostat is connected which will control the current or the field current. Okay, so energization of the field winding is depending on the rheostat value. Okay, so the another DC external DC source power or DC power source will be any kind of battery or rectifier or a control rectifier will be there. So let the generator we will see it is driven at the constant speed whatever be given by the prime mover. म्हणजे जर एखाद्या हा जर जनरेटर एका कॉन्स्टंट स्पीडने पळत असेल at that time the field excitation, that is if means what, field current which is used to excite the DC generator. So at that moment this field excitation is adjusted to the rated voltage at a no load. म्हणजे काय, तर फील्ड एक्साइटेशन जे आहे ते अशा प्रकारे मॅनेज केलं जातं की जे आपल्याला रेटेड व्होल्टेज देईल जेव्हा आपला लोड हा काहीही नसणार आहे. सो this value of voltage will become a constant value for further operations. Okay, so if we consider there is no any kind of armature reaction, then the generator voltage would be constant value. Okay, understood what I am trying to say? If there is a no armature reaction drop, so we will see what is armature reaction in next topic, but for now you just understood. See here in the figure, this is the constant curve, that is E0. If we neglect that armature voltage drop and armature drop, then whenever our internal characteristics will shows us the constant generated voltage at a armature end. Okay, but because of demagnetizing effect, what happened, there will be a presence of armature reaction, and due to that there will be a voltage drop due to armature reaction. So we will consider that much armature reaction voltage drop, then our next waveform, the next plot for the armature induced EMF will be like that. Again, there is IaRa losses, that is armature copper armature drop. Okay, so if we neglect or if you minus subtract that armature drop from our generated voltage, then also it will become that V curve. Okay, so now we will understand if this V will be V minus IaRa. If we will do that, sorry, V plus IaRa, that is nothing but this V plus this IaRa will become equal to E. Okay, so from that equation we can find E is equal to sorry, so from that equation we can understand generated EMF can be calculated by using total terminal voltage and by adding the armature drop into this terminal voltage. Okay, so this is the another method to find out the voltage built up in a generator. Okay, then we will move for the next. Then there is a self-excited generator. Okay, that self-excited generator which having again shunt generator, series generator and compound generator. So for now we will see open circuit characteristics for the shunt generator. So whenever there is a loading on a self-excited generator, then the output voltage of self-excited generator will be decreases due to the armature drop in the armature circuitry, and the demagnetizing effect of the armature reaction can minimizes or can subtract the total induced voltage. Okay, so this moment, as this is a shunt generator, the field current is independent on output voltage of the generator. Okay, so if there any reduction in a shunt field current which will cause the reduction in a voltage. So you can see here in a generator, if the armature field current will increase at that moment, so initially the whole both things are linear to each other. But if we will subtract the losses or subtract the armature drops, then it will becomes that constant. Hello, is my screen visible?
Yes, sir.
Yes, sir.
Okay, I think I'm really sorry that some internet glitches were there. That's why I rejoined. Okay, okay. So here the internal characteristics of the DC generator, which will plotted against current as well as voltage. So here you can also see whenever the current is going to increase, then the voltage become decreases. Okay, so like that way. Same case about the external characteristics. Here also, whenever the load current will decrease increases, at that time your voltage is going to decrease. But at a most condition, whenever the current will current will increase, at that time your curve will become like that. So that means it will decreasing the terminal voltage. So again we have already seen all that things. So in series also, if we'll see that in series there is a diagram like this, isn't it? And this will be a load. Okay, so here this field and this both are in a series. That's why the current flowing through these two is a same value. That's why whenever we will calculate the resistance, total resistance or equivalent resistance, at that moment both resistance value will be added and multiplied by the current flowing through that. So Rf resistance will be here and Ra resistance will be here. So once we need to find out the voltage drop across this phase, then we will do Ia, that is a current we will consider, which is same in two branches, and Rf plus Ra, that is a equivalent resistance, that means total resistance value. Okay, so we will add this value, then we will get E. So E is nothing but what? E is equal to VL plus IA काय नाही ह्याच्यात बघा, मग कपाटात एकदा बघा बरं. इथं कटर असला तर कपाटात असेल तिथं पलीकडे बघा बरं, इथं ह्या नाही तर पलीकडच्या कपाटात. Okay, so that E will become, that is generated voltage in case of the series generator is V plus I into bracket RA plus RL. है का? ठेवा इथं. अजून काय आहे का? काय आहे ते? टेस्टर पण आहे. ती घेऊन जावा तुमचा स्क्रू ड्रायव्हर. आणखी काय आहे त्याच्यात? मी आणलेलं आहे हे कन्झ्युमेबल, मला माहिती होतं. हो, मोकळे सरांकडून आणले. ठेवा इथंच ते. ठीक आहे. ओके, एक लेक्चर घेतो एवढं 15 मिनिट आणि देन वी विल डिस्कस. Okay, and now we will see about the characteristics of the compound wound generator. So in compound wound generator there is over compound, level compound as well as differential compound. Okay, so depending upon the number of series filters, the cumulatively compounded generators can be over compounded or flat compounded. That level compound means flat compounded, and that differential means what? Under compounded. Okay, so for an over compounded generator, full load terminal voltage is higher than the no load terminal voltage. Okay, so now here at a full load there is a current which is a full load current. That moment a flat compound generators, the terminal voltage at full load is equal to the no load terminal voltage. Okay, now in under compounded generator, the terminal voltage at full load is less than the no load terminal voltage. येते लक्षात? म्हणजे काय तर याच्यामध्ये इथं जर सपोज तुमचा हे असेल काय फुल लोडचा सिच्युएशन असेल तर याच्यामध्ये इथला काय असतो मॅक्झिमम असतो किंवा त्याच्या एवढाच असतो. ओके, equal to or sorry, equal to or higher than. In flat it is equal. Okay, with no load as well as full load both voltages will equal. Okay, and in case of the under compound or differential there is a minimum, or we can say less. Okay, so this is about the characteristics of the DC generator. Again we will see the armature reaction. So in armature reaction, that is nothing but what? Due to the magnetic effect, as already we have discussed the what we have discussed, that residual magnetism. Okay, who will tell me the residual magnetism? कोण सांगताय सांगा काय झालं आपलं? Who will tell me? अमृता शिंदे, अमृता जाडकर, प्रियंका, रितापुरे, प्राजक्ता, वेंकटेश, चंदना. Who will tell me? What is a residual magnetism? Nobody. Very good. So I will tell you the residual. Yes, is there anybody?
Sir, magnetic field remove केलं तर त्यात थोडंफार मॅग्नेटायझेशन राहतं.
Very nice. म्हणजे काय की if we remove magnetization of the material, then some kind of magnetic fluxes will remains there. Okay, so this is the residual magnetism. So it's same concept like armature reaction means what? The effect of the magnetic fluxes which is set up by the armature current upon the distribution of flux under the main poles of the generator. Okay, so this armature field or armature reaction having two effects. The first one, that it demagnetize or weakens the main fluxes. Okay, now before that you will just understand there is a two pole. This is a two pole generator, S pole, north pole, south pole, north pole. Okay, now you can see here is the rotation. See, here is a rotation. Okay, so before going for the effects, we will understand when there is a no load connected to the generator, that time the current in armature conductors will be zero or maximum. जर तिथं काही लोडच जोडलेला नसेल जनरेटरला तर करंट काय असेल आर्मेचर मधला?
Zero.
Very good. Then the current will become zero. So under this condition, there is some kind of magnetic or magnetomotive force, that is MMF, which is due to the residual magnetism. Okay, so हे जे काही जेव्हा करंट आपला फ्लो होत नाही, कधी जेव्हा लोड नसेल तेव्हा करंट अपने आप फ्लो होणार नाही. सो त्याच्यामुळं जे काही मेन पोल्सचे MMF असतं ते काय करतं तर एक फ्लक्स तयार करतं, थोडक्यात मेन फ्लक्सेस तयार करतं. ओके, आणि ते फ्लक्सेस जे आहेत ते फ्लक्सेस हळूहळू काय व्हायला लागतात, इट विल बिकम अ डिस्ट्रीब्यूट. ओके, पण डिस्ट्रीब्यूट होतात म्हणजे काय, इट इज डिस्ट्रीब्युटेड विथ रिस्पेक्ट टू polar axis. So there are two axes, that is MNA and GNA, magnetic neutral axis and the geometric neutral axis. Okay, so that MNA which coincides with the geometrical neutral axis or the GNA. So we already knows that the brushes are always placed on the MNA. Okay, you keep understand that MNA brushes always mounted or placed along the MNA. Hence, that MNA is also known as the axis of commutation. Okay, but it is known as axis of commutation. Now, armature conductor carrying current with no current in field coil. आता मी काय म्हटलं तर फिल्ड कॉइल मध्ये काही करंट नाहीये, परंतु आर्मेचर मध्ये करंट फ्लो होतोय. ओके, सो त्या मोमेंटला जी काही आर्मेचर कंडक्टर मधल्या करंटची डिरेक्शन असेल ती कशाने मेजर करता येऊ शकते तर फ्लेमिंग्स राईट हँड rule. Okay, so whenever this current will flows in a same direction, see here, इथं काय होतोय, करंट तुमचा पहा इथं एका सेम डिरेक्शन मध्ये नॉर्थ टू साऊथ फ्लो होतोय. एका इथं सिच्युएशन आल्यावरती काय होतं की जेव्हा हा MNA GNA पासून बाजूला सरकतो एवढा येतो, at that time there is a fluctuation in fluxes. Okay, so the conductors on both sides of armature will combine the MMF in such manner to send out that fluxes through the armature in downward direction. Okay, so what happens then, this current will be forced to flow through the downward direction. म्हणजे हा करंट काय होतो, खालच्या दिशेने फ्लो व्हायला लागतो आणि नंतर तो एक मार्ग शोधून तो एक्झिटला बाहेर जातो. ओके, हे कधी होतं, when generator is on load. Okay, जेव्हा no load असेल at that time there is no problem, but generator is on load, then two fluxes inside the machine, one which will produce the main field poles of the generator and other will be produce the current in a armature conductors. Okay, so now we will go for the two effects whatever are there. As we know the magnetic flux density is increased over one half of the pole and decreased over other half of the pole. So एक लक्षात येते का पहा, मॅग्नेटिक फ्लक्स डेन्सिटी आहे ती काय होते की एका पोल साठी इन्क्रीज होते बट दुसऱ्या पोल साठी ती हाफ होते. त्याच्यामुळं जे व्होल्टेज आहे ते हळूहळू स्लाइटली काय होतं, रिड्यूस होतं. ओके, आणि हे टोटल फ्लक्स रिडक्शन जे आहे त्यालाच आपण काय म्हणतो, फ्लक्स वीक होणे. ओके, तर त्याला आपण काय म्हणतो, फ्लक्स वीक होणे. आणि फ्लक्स वीक कधी होतात, when there is a demagnetization. Okay, That's why it will weakening the fluxes. Second one will be that flux wave is distorted. म्हणजेच काय की आपली जी फ्लक्सेसची लाईन असते म्हणजे मॅग्नेटिक लाईन ऑफ फोर्सेस असतात तर ते काय होतात डिस्टॉर्ट होतात म्हणजे डिस्टर्ब होतात. सो ड्यू टू दॅट ते जर डिस्टर्ब झाले तर आपला एमएनए काय होतो तर त्याच्या ओरिजिनल पोझिशन पासून तो काय होतो शिफ्ट होतो आणि तो मोटरच्या रोटेशनच्या अगेन्स्ट जायला लागतो. येतं का लक्षात. सो that armature reaction will establish a flux in the neutral zone. So armature neutral fluxes or armature reaction fluxes in the neutral zone will induce conjectural voltage that aggregate the commutation problem. Okay, म्हणजे याच्यामध्ये तुम्हाला कम्युटेशनचा पण थोडासा ओव्हरव्ह्यू दिलेला आहे. आता इथं परत आर्मेचर रिएक्शन कमी करण्यासाठी काय करता येतं तर to remedies or to recover the armature reaction, there is a compensating winding which placed under the slots in a pole shows. Okay, and this winding is connected in series with armature conductors in such a way that current in these two windings will flow in opposite direction to the flowing to the pole shows. Okay, and another one is that mmf of that is a magnetomotive force, which is already we know in electric circuit there is a emf, but in magnetomotive force there is a mmf is equal to, or we can say we can say that ampere turns or mmf of a compensating winding is equal and opposite to those due to armature conductor that are opposite to the pole faces. Okay, so this is the armature reactions remedies. So how like that way we can what we can say that we will remedy like a DC generator, and we can prevent the DC generator by from that all the dangerous hazards, that is a voltage drop and losses we can cover through the compensating winding and other two methodologies. Okay, so next part is I have taken here numericals. So here we will see numerical, one numerical we will check. Okay, as first numerical will shows us that a four pole generator, that means what, there is P is equal to 4, that already they have mentioned number of poles. Second thing, having lap wound armature winding. Here is a lap wound. I have already told lap wound winding is there, then A is equal to what?
MP.
A is equal to MP. Very good. A is equal to MP. But here is they haven't mentioned it is a simplex, duplex and triplex. So at that moment you will consider as a simplex. Okay, and in simplex M is equal to how much?
1.
1. So our A is nothing but what?
A is equal to P.
A is equal to P. So P is nothing but 4. So A is equal to 4. So this is the two values we have found out. Then armature winding has a slot of 51 slot. आता पुढे काय सांगितलंय की आर्मेचरची वाइंडिंग असते ज्याला आपण रोटरवरती ग्रूव केलेलं म्हणतो. ग्रूव म्हणजे काय, तर असे मध्ये मध्ये स्लॉट तयार केलेले असतात. तर ते किती स्लॉट दाखवलेत त्यांनी? 51 स्लॉट दाखवलेत, बरोबर. बट पुढे काय म्हटलंय पहा, इथं दिलंय त्यांनी आर्मेचर वाइंडिंग हॅज अ 51 स्लॉट, but here they have mentioned each slot containing 20 conductors. म्हणजे काय दिलंय त्यांनी, प्रत्येक स्लॉट मध्ये किती कंडक्टर्स आहेत, 20 कंडक्टर आहेत. आता मला सांगा, जर 51 जर तुमच्याकडे स्लॉट्स असतील आणि प्रत्येक स्लॉट मध्ये 20 कंडक्टर असतील तर टोटल कंडक्टर किती झाले?
1020. 1020 नाही 1020 होणार सर.
1020 होणार बरोबर. कसे तर मल्टिप्लिकेशन केलं की आपल्याला प्रत्येक स्लॉटचं आणि आर्मेचर वाइंडिंगचे स्लॉट टोटलचे जर प्रत्येकाचं मल्टिप्लिकेशन केलं तर आपल्याला काय भेटेल एक्सेप्टेड आन्सर भेटेल. त्याच्यानंतर व्होल्टेज जनरेटेड व्हॉट विल बी द व्होल्टेज जनरेटेड इन at 1500 rpm. That 1500 rpm is nothing but what? It is a speed value, that is n. Okay, assuming the flux per pole to be 7 milliweber. म्हणजे काय फाय दिलेलं आहे बरोबर. सो आपण प्रत्येक व्हॅल्यू इथे लिहून घेऊया. कशी लिहिणार? पहिल्यांदा आपल्याला इक्वेशन माहिती आहे. सो ऍज फ्रॉम इक्वेशन E इज इक्वल टू काय? E इज इक्वल टू ZP phi n into सॉल्व करताय का? हॅलो.
येस सर.
हा, कुठपर्यंत आलं? कुठपर्यंत आलं? किती आलं आन्सर? काय करणार पप्पा? Sorry. So here we have equation E G equal to Zn phi divided by 16 to P by A. So Z is nothing but what? Total number of conductor, that is 51 into 20. It is 1020. Phi already we have known 7 into 10 raised to minus 3. A is equal to P is equal to 4. का 4 घेतलं मी ते? That 4 P is equal to 4 is due to आवाज येतोय का माझा नीट? हॅलो सिद्धेश्वर.
Yes, sir.
ओके, सिद्धेश्वर चेक युअर इंटरनेट देन. सो हिअर आपण सगळ्या व्हॅल्यू ज्या वरती फाइंड आउट केलेल्या आहेत त्या पुट केल्या याच्यामध्ये आणि इक्वेशन सॉल्व्ह केलं तर आपल्याला काय भेटेल? 178.5 इज इक्वल टू आवर जनरेटेड EMF और जनरेटेड व्होल्टेज इन द मशीन. येतंय सगळ्यांना? कळतंय का?
हो सर.
ओके.